Hi, today we will design dog-legged staircase using manual plus Excel sheet. First of all, I will show you the problem statement. This is the problem statement. Length 5.8 meter, okay, width 2.8 meter, FCK 20 Newton per mm square, FY 415 Newton per mm square, floor to floor height 3.6 meter, landing 1.25 meter, support width 230 mm. Okay, fine. So just of all we write here length is 5.8 meter and width is 2.8 meter. Okay, floor to floor height 3.6 meter. Okay, floor to floor height 3.6 meter. Okay, FCK 20 and FY 415. Just me cross check. Yes, landing 1.25. Both landing will be 1. Where is the landing? 1.25 meter. This also 1.25 meter. Okay, so what is the risers? I will check. Okay, I will calculate the number of risers. The riser is 150 and tread is 300. Okay, I will just write this riser 150 and this one is 300. Okay, fine. So number of riser in each fly is 12. Just calculate it. Okay, how it is calculated I will show you. So number of riser is 1800 by 150, so it's 12 numbers. Okay, so it automatically calculated. Okay, 12 numbers. Number of tread in each flight, so 11. I will just cross check number of tread. Okay, just this is 11 numbers. Okay, effective span, how it is calculated? 3.3. Our 3.3 plus, I will show you the plan first of all, so that you will understand how it will be come 3.3 meter. Okay, this is the 3.3, how it is come 3.3 meter. Okay, effective span, this is 3.3, 1.25, this is the 1.25 landing plus 1.25 plus support. Okay, support by 2, support, but this is the effective length. Okay, this is the effective length and effective depth. So how I will calculate it in Excel sheet? I will just check it. Effective length, you can see effective length is 6 I will change, if I change the length, so you can see it will be changed. Okay, sorry, length, no, it's height. If I will change the height, the effective length also change. Okay, it's depend on number of rises and number of threads. So this is the 5.8 and this is 3.6. Fine. Okay, now effective length is calculated. Assuming clear cover 20 mm, a diameter of bar 10 mm. I will just assuming this data, modification factor 1.25. Okay, I will calculate the depth of footing, depth of staircase, depth of west slab. Just I will calculate the depth of wet slab. Okay, so how calculated depth of wet slab? See, L effective 20, modification factor I assume 1.25, so 415. So just I will check, this is the 241.2 mm, 241.2 mm. Okay, this is the depth required. Okay, so overall depth, so how I calculated the overall depth? This is the how I calculated the depth required, plus 20 is the cover, plus 10 mm the assumed diameter divided by 2. Okay, so this is the overall depth. This is the overall depth we need to require. Just we provide overall depth to 70. Okay, you can see I as provided the depth is provided to 270 and the effective is 245. Okay, how I calculated 270 minus 20 minus 10 by 2. Okay, this is the effective depth. Okay, so after effective depth I will calculate the load calculation on landing. How it was calculated? just the weight of west slab W1, so D under into under root R square plus T square, means riser square plus trade square divided by T into 25. It's the density of concrete. Okay, so this is the depth provided, capital D. So I calculated the load calculation here. So 7.55, it's the uh, weight. So 7.54 kilonewton per meter. Okay, now next I calculate weight of step. So how I calculate? 1 by 2 r into 25. So r is the riser, this is the 0.15 in meter, so 1.88. just I will check. R is the 1.88 kilonewton per meter. So we assume floor finish. Just I will see what is the floor finish load. Okay, lie load, I think I assume lie load 5 kilonewton. Just I will cross check first of all. Okay, I am not write it here, but we need to assume 5 kilonewton. If you can see the calculation, you will see assume lie load is 5 and floor finish 0.7. So I will assume it, lie load 5 kilonewton, and this is also 5 kilonewton. Sorry, the floor finish is 0.7 and lie load is 5. Okay, so here also I will write 5 and 0.7. okay, so this is the reactions after applying all the loads. 18.6 at 22.6 at, so I will cross check. This is the length. Okay, I will check whatever I calculate is correct. 22.6 at. Okay, I have this diagram. Okay, so all things are okay. Now next I calculate the bending moment. Okay, so I calculated the bending moment using, first of all I calculate the RA plus RB reaction. So 62.92, I will check. 62.92 is there. Yeah, fine. RA RB, it's okay. 62.92. now I calculated the maximum bending moment, 99.36. just I will check. I will manual calculation. Okay, this is the how I calculate the bending moment, maximum bending moment. After that I calculate the shear force. So what is the shear force values? I will check. This is the 62.92. fine. After this is the AST requirement. First of all I will check the depth against bending moment. Okay, I will check the formulas. Check for depth against bending moment. So we know the maximum bending moment, and by using the formula 0.138 FCK BD square, this is for our grade of steel is 415. So that's why we use this formula. So our required depth is 189 and we provided 270. just we see the provided depth. See, this is the provided depth. Okay, fine. So after that type of steel, main steel, this is the AST required. How I calculate the AST required? So see, this is the AST required. Okay, AST required after spacing of bar I calculated. So we provide 16 mm bar. So I will just change the bar diameter required, AST required spacing, okay. Just we provide the AST provided. ठीक है. I will change this spacing to 150. Okay, so this is the main steel. So I calculated the main steel. After that distribution steel, this is how I calculated the distribution steel, 12% of B into D. So which diameter I assume 10 mm bar. 240 I provided the distribution steel. So I will change this 240. Requirement is 242 and we provide the, okay. Now all the things we, now after that check for deflection. How I check for deflection? So this is the AST required, this is the AST provided. What's the AST required? 1258 mm square and provided 1340 mm square. Okay, all the things are okay. Now I percentage of still I calculated. This is the deflection check formulas. I will show you how I calculated the deflection check. See, so this is the deflection check formulas. 0.58 FY AST required by AST provided. Okay, so FS, we calculated FS. So after calculation of FS, so we calculated the modification factor. So by using this formula I calculated, you can use this formula and you can go with uh, IS code page number 415/2000, page number 38. You can assume this also. Both things are okay. I think I wrote this in IS code values, so you can see. You can assume modification factor. See, here is the modification factor. You can assume modification factor, you can calculate by using these FS values. Okay, so this is how I calculated the modification factors. Okay, so you can use this formula, and otherwise you can use IS code values also. Both are okay. Now I calculated the actual span by depth and permissible. Okay, now deflection is also safe. Now I calculated shear check. How I check the shear, so I will show you by manual. Okay, now first of all I calculated tau v max. So vu I know, so we calculated tau v max 0.257. So this is the 0.257 grade of concrete, I know that. So this is the tau v max. Okay, 0.257. So according to our grade of concrete I calculated the tau c. So how I calculated the tau c, just I show you. uh, uh, just I'm checking tau bd. Okay, uh, I think this is tau bd. There is the tau c max. Okay, tau c I calculated using the tau c. I know the grade of concrete and percentage of steel. So what is the percentage of steel I provided? Just I will show you. 0.5% is still required. Tau c 0.48. Okay, so tau c is 0.48. so you can see which grade of concrete we have. 15% 0.48. Okay, so according to 0.48 we calculated the tau c. Okay, so after both checks are okay. Okay, so after that these both things are okay. So next check was check for already we done check for deflection development length calculation. Okay, so how I calculated the development length? By using this formula. So tau bd I calculated 1.2. Okay, but IS code says we increase by 60 percentage, so this is a 1.92 Newton per mm square. So we required the development in 2 for 52.18 mm, so we provide 760. Okay, so see how I calculated. This is the development length. Okay, this is the detailing of, this is the final conclusion of our staircase design. Just I will show you the plan also, so you can understood. This is the plan of the staircase. Okay, fine. Thank you so much. If you require this Excel sheet, just WhatsApp me on given number. This is the number, you can WhatsApp me. I will provide you Excel sheet. Okay, fine. Okay, thank you so much.